Good afternoon, everyone. This is Mr. JC. I hope you're all doing fine. This is our first video tutorial that I'm going to post on your Google Classroom, and I will also be uploading this on the YouTube channel that I've created for you, and I'll be sending you the link of this YouTube channel by email by the end of the day today. In today's class, first I'm going to give you a very quick recap of what we did in our last class on Monday last week, and then we'll try to solve logarithmic equations. We'll talk about the properties of logarithms. We'll try to write a logarithmic expression as the sum or a difference of logarithms, and then we'll do some exercise. Let's begin with the laws of exponents. We have already discussed these laws in our last class on Monday, but just to give you a very quick recap, remember when two numbers with the same basis are multiplied, you add up their powers. Having said that, if you have 3 to the power square, for example, and 3 to the power square, 3 to the power 2, then the answer of this is going to be 3 to the power 4, which is 81. The same thing happens when you divide two numbers with the same basis, then you subtract their powers. The third law that we discussed was if a number has a power and again it has a power, both the powers are multiplied. Like for example, if you have 3 to the power 3 and then square, then the answer of this is going to be 3 to the power 3 twos are 6. Moreover, we discussed if a number is in the denominator and has a negative power, if you take it in the numerator, the power becomes positive. The same thing happens if the number is already in the numerator and has a negative power. You bring it down to the denominator and the power becomes positive. The last thing that we discussed was if a power 0 equals to 1, which means any number like say 16 to the power 0, answer is always going to be 1. Moving on, also we discussed that if two numbers with the same basis are equal, their powers are equal. For example, if we have 3 to the power x equals to 3 to the power 7. Now because the bases are the same, so the powers have to be the same, so the answer of this is going to be x equals to 7. The same thing happens when the powers are the same. Like for example, if we have x to the power 5 equals to 7 to the power 5. Now as you can see, the powers are the same, so the bases have to be the same, so the answer of this is going to be x equals to 7. Let's answer this question here. This is a very interesting question. Let's say we have a function g of x equals to 5 power x minus 3. The first part of the question is what is g of minus 1 and what point lies on the graph of g. To solve this, since you know that g of x is actually y, so we can say that y equals to 5x minus 3. Now you have to find the value of y when x is minus 1. So let's plug minus 1 here in place of x, minus 3, and then you get 1 over 3 minus 3, and then I believe the answer for this is minus 14 over 5. Which means if x is minus 1, then the y is minus 14 over 5. So what point lies on the graph? Minus 1 and minus 14 over 5. I will just erase this now. For the second part of the question, this one here, the question says now if g of x equals to 122, please, then what will be the value of x? So in that case, I'm going to use the same function here. Now g of x is 122, so 122 equals to 5 to the power x minus 3. I'm going to take the 3 on the other side, so that's going to be 122 plus 3. That will give me 125 equals to 5x. Now, you know that 125 can be written as 5 to the power 3 equals to 5 to the power x. The reason I wrote this 125 as 5 to the power 3 because I wanted to have the same basis so that I can establish that when the bases are the same, the powers are the same. So x is equal to 3. Now we have just found out that the x equals to 3 when y was 122. So now you can guess what point lies on the graph. Yes, you're right. It's 3 and 122. Moving on. The next part of the question says, the part here with the red, that if 3 to the power minus x equals to 2, then what does 3 to the power 2x equal to? This is very interesting question now because we have 3 to the power minus x equals to 2. Our objective is to transform this thing into this one. As you can see, this one here in our question 3 has a negative power, but in our end result there is no power with the negative sign. So first thing that we have to do is we have to make this power positive. What I can do for this is 3 to the power minus x equals to 2. I'm going to take the negative power here and negative power here, and this will give me 3 to the power x equals to half. Now as you can see, we are getting close to this thing. We already have a positive power now. All we need to do is now we have to take the multiply this with 2, and to do that I would say 3x equals to half. I'll take the square of this side and the square of this side. Now we know if a number has a power and again it has a power, both the powers multiply. So the answer for this is 3 power 2x equals to 1 over 4. This is the answer for the second part of the question. You can now pause the video and you can take your notes. Moving on. This question is very similar to what we just did, and I want you to answer this question, and then you can share your answers with me through the email, and I will then let you know if your answers are right or wrong. Right, look at these two questions. These are very important questions. The first part of the question says, suppose that 2 to the power minus 2x, 2 to the power minus 2x is equal to 1 over 3. We have to transform this thing into this one. So once again, as you can see, our end result has a positive power, but the number that we are starting with has a negative power. So first thing first, we need to make this power positive. To do that, I'm going to multiply this. I'm going to take a power negative 1, power negative 1. Now we know if a number has a power and again it has a power, both the powers multiply. So minus 2x times minus 1 is going to be 2x. So 2 power 2x is going to be, so 1 over 3 and a negative 1. So this is going to flip this fraction. So answer is going to be 3. Now we are 2 to the power 2x equals to 3. Now tell me, can I write this thing like this? Certainly I can, because we know when two numbers are when the two powers are multiplied, then I can always split them like this. So now 2 square is 4 and x equals to 3, which is our end result. So that's what we needed to find out. 4x equals to 3. Once again, I would like you to pause the video just to look at the results once again, how I solved it, and then try to answer this question. Once again, you can share your results with me, and I'll try to get back to you as quick as I can. Moving on. Now, surprisingly, logarithmic functions and the exponential functions both have more or less the same properties. You can say they are the real sisters. They look different, but they have the same habits. So therefore, we can always convert the exponents into logarithms and logarithms into exponents. And this is how we do this. Let's say we have x equals to a to the power y. If you want to write this thing down in the form of logarithm, then look at this. The base here, base of exponent a here is a. When you convert this into log, the base is still a. All you need to do is that switch the places of x and y. So log base a x equals to y. Keeping this in mind, let's try to answer some of these questions. I have 1.2 power 3 equals to m. I want to convert this into log. Can I write this thing as log? Now, because the base here is 1.2, so the base of log should still be 1.2. All we need to do is now switch the places of 3 and m. So it's going to be log 1 base 1.2 m equals to 3. Now, how can we solve this thing? I will talk about it later. I want you to convert this into logarithm by yourself. The next part is, if you already have something in logarithmic form, how can you change this into exponential form? So we know the base of log is a. So the base of this exponential function should still be a. And then what do? We switch the places of 5 and 4. So a to the power 5 should be equal to 4. Now, as you can see, I have converted the logarithm into the exponents. This question I want you to try by yourself, and once again, if you need any help on Wednesday during your class time, I will be online. I will be available live for the live chat on Google Meet. I've already created a group for you, so you're most welcome to sign in and ask me questions about all this. Moving on, solving logarithmic equations. That's how we convert the exponents into logs and logs into exponents. Let's solve the first question. Log base x 27 equals to 3. So we have to find the value of x. To do that, because the base of log is x, so we can easily convert this into exponent. Because the base of the log is x, so the base of exponent will be x, and then we switch the places. So x cube equals to 27. We know that we can write this 27 as 3 to the power 3. Now, since the powers are the same, as you can see, so which means the bases should be the same. So x equals to 3. It is as simple as that. Let's solve another question. In this question, we have log to the base 2, 3x plus 5 equals to 3. So let's convert this into exponential form. So because the base is 2, so the base of exponential function will be 2, and then you switch the places. So 2 comes here, 2 comes as the exponent here, and then on the other side you have 3x plus 5. It's easy to solve now. 2 cube is 2 to the 4, 4 to the 8 equals to 3x plus 5. It's simple algebra. Take the 5 on the other side, so 8 minus 5 is going to be 3 equals to 3x, and x is equal to 1. That's how you solve this question. I would like you to answer this question by yourself and share your answers with me. Moving on, properties of logarithm. Remember, here are some laws and properties of logarithm. Log of 1 is always 0, no matter what the base of log is. So log a1 equals to 0, which means log 7(1) equals to 0. So no matter what the base is, as long as you see 1 here, answer is going to be 0. The second property of logarithm is, if the base and the number next to the log are the same, then the answer is going to be 1. Let me first explain these two things for you. Look at this one first. Log a1 equals to 0. So I want to prove that why log 1 is always equal to 0. To see that, let's convert this into exponents. So because the base of log is a, so a, and then you switch 1 and 0, so 0 comes here, equals to 1. Now We have already studied this property that any number with the power 0 is always equal to 1. That's why this property holds true. For this one here, again, the base is a. Now we have a here, 1 here, so I'm going to switch the places. So a to the power 1. You know, the power 1 of any number results in the same number. So that's what this property says. The third property of logarithm is you have a number a which has a power log base a. So this base and this number here both are the same. If this base of the log and this number, the base of the whole number is the same, then the answer is going to be the number next to the log. The last property that we are going to discuss now is log base a to the power r is always equal to r. There's a property of log that we are going to discuss later that says whatever number is after the log which has a power, the power always comes at the front. Like for example, if I have log to the power base a, let's say x square for example, then this thing can always be written, this power always comes at the front. So this can be written as log 2 log a x. Now in this case, because the value of x here is a, so 2 log a, and according to the property here, log a should be equal to 1, so 2 times 1 is going to be 2. In this case it is r here. Keeping all these four properties in your mind, try to answer, I'll go back to these ones later. Keeping these four properties in your mind, I want you to answer these 4 questions and share your answers with me. I will now go back to properties of logarithm. So if you remember, when I started this lesson, I told you if two same numbers are multiplying, you add up their powers. So it's going to be a x plus y. The same thing happens with the logarithm. If two numbers are multiplying and you take the log of these two numbers, then to simplify, the log a of m plus log a of n. The same thing that we did with the exponents, if you remember. We said that when two numbers divide each other, you subtract their powers. Same thing happens here. Look, m and n are dividing each other. So when you take the log, you just write them as log m minus log n. And this is the property that I just told you about, that if a number after the log has a power, the power comes at the front. So this is the property that we just talked about. Moving on. So this is what we have already done. Let's move on and let's use these properties to answer a few questions. This one is pretty simple. This one says that because 7 over 3 log a, so we can use the second property here. So according to the second property, it should be equal to log a 7 minus log a 3. For the second question, as you can see, we can use the first property. Look, the right hand side of this first property is very similar to this question. So we have log a5 plus log a6. Now the important thing that you have to remember here is the bases of the logs should be the same. If both are a's, both are 2's, both are 3's, only then you can apply the first property. So according to the first property, this should be equal to log, the base in this case for both logs is a, so I'll use a, and then 5 times 6, which will be equal to log a 30. Right, so now there are 3 questions for you. These are the exercises. I want you to answer these questions and share your answers with me. Thank you very much. And if you have any questions, as I said again, you are most welcome to write me an email, or I'll be live for the live on Google Meet on Wednesday from 8:30 to 9:30 in the morning. All you need to do is open your Gmail, and from there you can chat with me for any questions. Thank you very much, and soon I'll be posting another video for you.